All right, here's question 6 on this math subject GRE practice test. What we're told is that f is a real valued function and that f of x. In other words, if you take the function and you compose it with itself, you're left with just x. Another way to think about that is if you apply this function a second time, you kind of cancel out what you did the first time. And what you're asked is which of the following could be the graph of this function? Well, I think the easiest way to do this problem, I might be abusing notation a little bit here, but I think the idea is pretty solid, is instead of thinking about f of x being equal to x, sort of take f inverse of both sides of this equation. That would cancel out one f on this side, so I'd be left with just f of x, and on this side, I'd have f inverse of x. Think about what this is asking. It's asking, is the function the exact same as its inverse? Do you remember how to find the inverse of a function based on its graph? Well, the first thing is you need the function to be 1-to-1, not the case in part C, but we'll get back to that later. These other four are all 1-to-1, so we can talk about their inverse. The idea with an inverse function is you're really just switching all the x and y coordinates. So if the point, I don't know, -2, +2, it looks like, is on the graph of the function, then switching the x and y, we get +2, -2, would have to be on the graph of the inverse function. I guess that's worth writing down. If you're trying to find the graph of f inverse of x and you have the graph of f of x, what you can do is just switch all the x and y coordinates. Turns out geometrically, that's equivalent to reflecting over the line y equals x. Maybe I can kind of demonstrate that up here. The line y equals x is just this diagonal line right here. Think y equals mx plus b, where m is equal to 1 and b is equal to 0. If you take any point, like this point at -2, 2, and reflect it over this line, where it lands to -2, will be the point where the x and y coordinates are just switched. So now that we know how to find the graph of the inverse function from the graph of the function, we can just look at these guys and ask ourselves the question, is the inverse function the exact same as the function? Let's start with A. Here's my line y equals x, or at least a decent approximation of it. If I took this graph and I reflected it over this line, I'd end up with something that looks kind of sort of like this. Not the best drawing, but whatever, good enough. It's clear that blue is not the same as black, therefore A is not the correct answer. What if I took the graph in B and reflected it over this line? Well, that would give me something that looks kind of sort of like this. Again, not perfect, but maybe good enough. Clearly black is not the same as blue. B is not my answer. For C, because this function is not 1-to-1, its inverse isn't even going to be a function, so I'm kind of abusing notation here, but the same idea applies. If I took this graph in black and I reflected it over this line in red, what I would get is something kind of like this. These are actually kind of fun to draw. Blue is not a function, it doesn't pass the vertical line test, and that's because black is not 1-to-1, it doesn't pass the horizontal line test. But ignoring all those technicalities, it's clear that blue is not the same as black. C is not the correct answer. Maybe I'll jump down to E here. You might think that if we reflect over this line, this black is going to kind of land on this black, but that doesn't quite work out. What I instead get is something that looks more like this. Blue is not the same as black. E is not the answer. Through process of elimination, I'm feeling pretty good about D. Maybe you can kind of see how if we took this portion of the graph and reflected it over this line, it would land on this portion of the graph. And if we took this portion of the graph and reflected over this line, it would land on this portion of the graph. If you have a hard time drawing these graphs in blue, you really don't need to draw the graphs in blue in order to eliminate these answers. You can also just kind of pick some points. Like for A here, this point where x equals 0 and y equals 1 is clearly on the graph in black. If I switch the 0 and the 1, I get 1, 0, this point that you see right here, which is on the graph in blue. But in order for f of x to be the same as f inverse of x, this point 1, 0 would also have to be on the graph in black, but it's not. Even if I hadn't drawn the graph in blue, I could tell that this point was not on the graph in black, therefore A is not my answer. You got to be a little bit careful with that approach. I don't know, this point at -1, +1 is on the graph in black. And if you switch the x and the y, you get +1, -1, which is also on the graph in black. That doesn't mean that f of x equals f inverse of x, because in order for f of x to equal f inverse of x, that must be true of all the points in black. And I've just shown it on one point in black. If we take another point on black, like where x equals -2 and y equals, I don't know, 4 or so, you switch these coordinates, you get 4, -2, 1, 2, 3, 4, -2. This point is clearly not on the graph in black, so f of x is not equal to f inverse of x. Anyways, the first way that came to mind for me to solve this problem is to compare f of x and f inverse of x, but that relies on you changing this into this. And maybe you're not comfortable seeing that. If you're not, that's okay. As is typically the case, there's another option in solving, and that's just to use function composition. Right? See if f of x equals x for all values of x. Or maybe a better way to say that is see if you can eliminate 4 of these 5 graphs by finding values of x for which f of x is not equal to x. You typically don't have to look too hard. Like for a here, if I find, I don't know, f of 0. The way I evaluate this is I start from the inside out. I figure out f of 0. That's asking me what is the height of the graph in black when the x coordinate equals 0. We know from this point that that's equal to 1. So this is equal to f of 1. This is asking me what is the height of the graph in black when x is equal to 1. That appears to be, I don't know, like 1.5 or so. I don't really care what it is. I just want to know, is it equal to 0? It's clearly not equal to 0. The height of this dot in green is clearly not 0. So f of 0 does not equal 0. What that tells me, again, is that A is not the correct answer. We can do that same logic for B. You could pick 0 again or pick some other point. Pick -2. f of -2. Using this point that I've already drawn, I know that f of -2 equals +2. So this is f of +2. f of +2, I come over here to an x value of 2, and I estimate this height. What is it? I don't know, like a half or so maybe. Again, I really don't care what it's equal to. I just care, is it equal to -2? No, absolutely not. This point does not have a height of -2. B is not the correct answer. You do have to be a little bit careful using this approach, though. Consider graph C here. If I evaluate f of -1, working from the inside out, come over here to -1, and I figure out the height is +1. So this is equal to f of +1. For +1, I come over here and I figure out the height. It looks like it's -1. Oh, look at that. f of -1 equals -1. Looks like it's satisfying this criteria. C must be my answer. No. In order for C to be your answer, this has to be true for all values of x. We just happen to find one value of x for which it works. Using this method, we can't yet eliminate C. At this point on the test, you might move on. Come down here to D, try something similar. I don't know, f of 1, sure. Well, let's see, f of 1 using this point right here appears to be -1. So I get f of -1. f of -1 using this point here appears to be 1. Again, f of x appears to be equal to x. So maybe C is my answer, maybe D is my answer. I could eliminate E if I happen to choose, I don't know, this point, f of -2. I know that f of -2 is 4, so this is f of 4. f of 4, I'm asked about the height of 1, 2, 3, 4, the graph right here. What's the height of the graph right here? I don't know, it's way the hell down here. Okay, is it equal to -2? No, absolutely not. It's equal to like -20 or 30 or something. f of -2 does not equal -2, so E is not my answer. I've narrowed it down to either C or D. Let's see if we can eliminate one of these two by starting at a different point. Oh, here's a nice point that's on my graph. f of 2. Well, let's see. f of 2 is equal to 0. So this is f of 0. What's f of 0 equal to? Well, that's equal to 0. 2 is not the same as 0. C is not my answer. By process of elimination, I figured out that D, again, must be the right answer. As is typically the case when there's multiple methods, the slightly more sophisticated one will get you the answer a little bit more quickly. The challenge would be recognizing that this is kind of sort of equivalent to this, up to the issues with one-to-one functions that I discussed in part C, and that you're able to figure out what the graph of f inverse looks like just from looking at the graph of f of x.